enable the sharing?
I started recording the presentation.
Hey, all, good to see you.
Hey.
Hey.
Want me to start my cam?
Nah, either way, whatever. I just wanted to say hi. I know I had messaged some of you guys, so wanted to put a face to the name.
Yeah. So, Winos, are you hosting? Can you enable the sharing? I can't share screen.
Yeah, one second. I'll make you host, so that'll give you.
Okay.
Then you can probably. Okay, you're host now.
Okay, cool. Okay, cool. Let's get started. Welcome to the community call for February 2022. In this sync meeting, I'll do a brief community updates, and we will have guest speakers to share some great stories. By the way, I'm Raymond. I'm from Hudi PMC member team. So quick update from the community. As always, we're seeing really good activities over the GitHub. This is a screenshot from GitHub Insights. Over the past month, we have 126 PR landed. We have closed 53 issues. We have 46 others pushing commits, over 100 commits. Definitely great trends there. Quick highlight on the community updates. Some regarding the release. So the 0.11 release will be around late March. Definitely a great deal of improvements there and new features, highlighting things like metadata table and indexing, Spark SQL support, a great new supports around Trino, AWS Glue, BigQuery. Some great news announcing OneHouse. So we announced this company around early Feb. Definitely aiming for a great deal of late house solutions. Also highlighting great reads from OneHouse commitment to openness, written by Winos, and also another great success story from Robinhood, building data lake with Hudi on AWS. So I put links there. Feel free to check out from the slides. So I would definitely hand over I will now hand over to our guest speakers to speak about their stories. Felix, over to you.
You're on mute, Felix. I think you're still on mute.
Okay, sorry. Okay, so I was just asking. I'm sorry. Yeah, so I was just asking, can you just go to the next slide so we can just thank you all. It's nice talking to you all. So who am I? So I'm a system architect at Philips and having experience at different domains, spanning from the telecom, banking, and healthcare, and currently working on the transactional data lakehouse and implementation of the data streaming and stream processing. Mainly working on the data architecture, so doing the data cataloging, canonicalization, and setting up that layered architecture. So next slide, please. So our goal, so why we have, so we are trying to build a transactional data lakehouse to support various businesses and avoid data silos. And also it will enable us to derive insights and data informed decisions by avoiding the data duplication, and also at the same time support diverse workloads that we are having trouble, like the BI, AI, ML, data sharing and analytics, since it's lacking a centralized, or so having data silos is the main issue. So next slide, please. Yeah, this is the reason. So as you can see, so this is where we are today. So we are having the different business units that the Philips has different applications, and each application is storing the data. It can be an application, can be a monolith-based application. It can be a microservice-based applications, and they might have their own choice of databases, and the data is not fully in a standardized format. So you can see the data silos. So the analysis is not possible, and differing data quality, as I mentioned, some data is aggregated, some data is non-aggregated, no centralized analytical store. Because of that, we don't have that the full visibility of what data we have. And then a common data vocabulary. So we are missing a data common vocabulary. So the data querying across different data sources is very difficult, and maybe really impossible. So we are trying to avoid and address all these things with our centralized transactional lakehouse. Next slide, please. So I will just stop for questions at the last. So if any questions, please park it for till the last. So our environment, what we are mostly on an AWS, and the services that we are currently using is AWS EMR, RDS, AWS S3. I forgot, I missed a couple of things. The Redshift is another thing. Then the data sources is Kafka and S3. These different applications, I will just, when I go to the architecture, I will just show you the data sources, how is it being acted upon. And then the orchestration perspective, we are using Apache Airflow. It's a managed AWS one. And then the access control perspective, that is an important piece that we are trying to achieve and like ensure the access control via the lake formation and having a centralized access control to all these different data stores. Then BI, we are using a BI tool like a Sisense, and all these Sisense, the SageMaker, interactive access cases, Presto SQL, all these things are reading data from our transactional lakehouse powered by Apache Hudi. Next slide, please. So this is the overall architecture, as you can see. So we have different applications, and that is streaming data in a canonicalized or standard format into Kafka. That ensures the schema and the schema evolution and enforcement. And then it will be retrieved or consumed by this Spark structured streaming jobs with Apache Hudi. And this we are persisting the data catalog of those tables into the Glue data catalog. And then we are having these access cases like the notebooks or the API access cases, reports, then the business dashboard, the BI tools, and the SageMaker is being used for the machine learning platform and its notebooks. So all these things are accessing through the EMR Presto, the EMR Spark, and then it is coming over through this lake formation as a centralized access control, which ensures the data visibility and controlling the access control to each of those things rather than duplicating the data. So we leverage the lake formation to hide the columns that that is not supposed to be seen by a given user and its role. So that way we are having that architectural principle of eliminating the data duplication as much as possible. And then as you can see, the Apache Airflow, that is something that we are using for this batch jobs. There are transformation jobs that is running to just support that the Hudi data sets, that is the lake house, where we have a layered architecture. So we have a raw layer, silver layer, and golden layer. This Spark pool, that ETL jobs that you can see in down, powered by that Airflow, that is something that will run in a configured interval or by an event driven. So that will just transform the data, the fashion that we want for a business or a given access case in case it's needed. And then everything is controlled or monitored by Yelk, that is Elasticsearch, Logstash, and Kibana. So you have that the distributed the monitoring since when a transaction starts from the application, so all the way through the ingestion, so you can see in a centralized place by the Kibana, so you get that the full visibility. And the the Apache Hudi is helping us to have that asset transaction and this deduplication, compaction, etc. So let's go to the next slide. Things that have worked well. So Hudi helps us to build a more trustable transactional lake, especially the asset transaction enforcement, and then the upserts and deduplication on late arriving data. Since we are using Kafka, sometimes what happens is we might get, like, there might be an issue on some of the data. So that may go to the dead letter queue, or you can say that we are creating a DLT when there is a data is having some corruption, and then later it is getting reprocessed. By that time, there is another event has already occurred, and then that is having that fresh data. So we were having troubles, but like the Hudi that solves that problem by just like looking at that the persistent data versus this newly arriving data, and if the persistent store has the new data, then it just ignores that the actual the new coming data, so, or old data. So that is a big thing to have that trustability and not inflating with the duplicate data or old data actually. So then support for schema evolution. So that is another thing. So from at the Kafka event stream itself, we are enforcing schema by the schema registry in Kafka. So the same thing. So since we are having that schema evolution in the streaming, so this Hudi also have that schema evolution. So it is helping us to have end-to-end schema evolution rather than just having some issues in between and having a different management of the schema evolution. From an integration perspective, we are doing some volume testing. So now we are in a situation, or we are in the phase where we are doing the volume testing and ensuring all these access cases and getting into production. So we were doing some benchmarking. So the Presto SQL, we are trying to use it for the interactive access cases where we were just seeing 3 to 4 second latency on demand aggregation queries on top of 1 trillion records partition by day and sub-partition. And each partition is having around 518 million records. It's a small data set compared, but in our actual production. But so we just have some benchmarking, and seems it's pretty quick. We were expecting to get better, a little more performance by the clustering. So, but yeah, I will get into that in the next slide. But and then the automatic syncing to external Hive metastore, like a Glue data catalog or this MySQL database, those things were a pretty good thing that I can see, or it was helping. So having a common interface for all these big data engines to query upon. So that was rather than having a glue crawler, that we had some issues initially with the glue crawler and things like that. So it seems like this is a much better way that we can just address things. Then our community support, that is last but least, like community support and timely response on issues. That was one thing I've noticed. I've been into different communities and I've seen that the great response from the community and the people from this community was amazing. So kudos. Next slide, please. So the adoption challenges. So yeah, even though we have a good level of documentation, still I'm seeing when we get deep into the implementation or the architecture and leading the team, it seems like some of the information regarding troubleshooting issues and configurations and their dependencies on other configs, that is something I'm just seeing as missing, or like we could have better documentation. So we will be able to understand when I change one configuration, what is that impact on the other configuration, whether the other configuration is still applicable when I have enabled something. So it's like, it's a big thing I'm just saying. Then the clustering is another thing, not able to perform clustering as it causes out of memory error. It seems maybe I'm just not doing things correctly, but I'm seeing that the clustering it's happened, or whatever data I'm having, it is getting into the driver memory or things like that. So it's not being able to do that clustering properly. Even I'm just mentioning one partition at a time, I'm having trouble. So or maybe a help on that one, it's a very helpful for us to get those access cases, much better performance and interactive access cases. So then the missing following informations, the example or strategy on how to perform a clustering on large tables. And async clustering is not working, or we were having trouble on getting that working on a 0.9.0 Hudi version on AWS EMR 6.5.0. So, and then clustering on continuous MOR tables. We are currently using MOR tables since we have some near real-time ingestion access cases to support. And so the clustering, it seems like, I'm not sure, like in my understanding or just reading, just like the clustering, it just cannot go in parallel, or maybe so those are some of the things. It's not clear from a documentation perspective, the MOR table and COW table, what is difference and things like that. So metadata table is having issue on a 0.9.0 Hudi version, and I've raised a GitHub issue. So like it's mentioned that it's already addressed in 0.10.0. So I'm waiting for EMR 6.6.0 to be released to get that addressed. And the MOR table, the data sizing and compaction of the Parquet files, most of the time, so we are having inserts and it is creating new Parquet files, but that getting compacted into the optimal size without having a clustering is something that I'm just seeing. So I'm having some trouble on that one as well. So, but overall, things are going good. So we were able to ingest and have in minute latency. So we are trying to tune that to less than a minute or a half a second, or half a minute. So we are trying to tune things and getting this one as a near real time, near real time performance data pipeline in overall. Next slide, please. And then the wish list. So I'm like, yeah, so these indexes and the secondary indexes, maybe that will definitely help. And the multi-streaming ingestion to the same table is something I'm just, because sometimes we will have multiple Kafka topics, so similar data, but if like currently in my knowledge, like the multiple streaming jobs cannot just write into the same table. Maybe I'm wrong, and like this is something that I would be looking at. And then the automatic handling of failed data routing. For example, I am getting streaming data. I'm just working on the streaming. So let's say one out of that stream, like many data records in a streaming, it's a corrupted data for some reason. So if that particular record is it might cause that entire pipeline to just get into halt. So we might, I'm just expecting something like the Hudi will help us if there is a data issue, that particular failed record can be routed to a different Kafka topic, something like a dead letter topic or something like that. So in that case, that will then the stream should continue rather than just being retrying that same failed record. We know that if there is an issue, there is no point in retrying that. I've seen something like that, but I'm not sure whether it is supported in the actual the Hudi, the latest versions or something like that. So, or is it just a patch that is currently available? Or then the documentation on the failure or disaster recovery, table corruptions, things to avoid, etc. So that would help us to get confidently into production. So that is something I'm just maybe I'm just seeing as a next step or a wish list. Then the CI, the Hudi CLI has more features like a metadata table queries or cluster related queries, and so we can just get more information regarding the new features, or at least if their documentation is missing, it's already supported in the CLI, then documentation needs to be updated, or we can just have that. And the real wish list is support for a subsequent data ingestion to cloud storage. So maybe that will be awesome. So yeah, that's all. So can it so this the questions, any queries?
Hi, this is Gatsby. I have a question. What kind of problem do you have with the meta table in Hudi 0.9?
Okay, so what is happening is sometimes the compaction, there are the compaction in flight, and then at the same time when that clustering is running, so then it is throwing some exceptions. So if I can just give you the GitHub issue, and Shiva has confirmed that, and Prashant has confirmed that there were 2 GitHub issues that is already addressed, and it is fixed in 0.10.0. I don't remember the GitHub number. It is something like 4206 or something, if I'm correct. So I can just give you those, but they confirm that it is addressed, that listing issue in 0.10.0.
Okay.
Yeah, it is not happening. That is another thing. It's not always happening. I'm lucky I got that issue upfront. So so I just I just asked that, and then it seems there was an issue. It's already addressed in 0.10.0. So
Okay.
that happens when there is a lot of writes. The fast ingestion is happening at that time. It's mainly occurring.
Nice overview, Felix. Thanks for sharing. And I think there's a bunch of messages in the chat window too, as I'm sure it's hard to see as you're talking, but there were some people that threw in suggestions and things.
Okay, perfect. I will go over that now, since I was just trying to not taking a whole lot of time, and then not having the other speakers time to talk. So
no problem. Cool. And then I guess we can spin some of those into offline discussions as well. Based on the time, we probably should move to the next speaker, but thanks, Felix.
Yeah, thanks, Felix. That's great sharing and points raised. So over to Istvan.
Istvan. So hi guys, my name is Istvan Darvas. I come from Hungary. I will be very quick because most of my issue was covered by Jose, Felix, which is your name, what you like. So please, the next slide. Okay, I work for a small Hungarian company. It's a secret control GPS. Or use case is mostly IoT. I will cover it later. I've got a master's degree in programming mathematics, and most of my career I was a system engineer and later became a software engineer. Actually, 5 years ago. 5 years ago. Next slide, please. I will be very quick. So actually, this is a use case. We have 150,000 vehicles, trucks, vans, personal cars, which we provide, which we need to provide logistic and fleet management. So this is not our cars. We provide. Sorry, my English is a little bit short, but I'm going to try to do my best. So peak time we have approximately 15,000 event. This is why we need something, because 3 years ago I started this company. Work for, and the legacy system is not able to handle this kind of load. We need to drop a lot of data, and we can't keep up in the legacy system with historic data. So we cannot do anything, just the daily and the monthly reports. So this I was hired to put the legacy system into the cloud and try to find a solution. How should we handle this kind of load? We mostly want to drive the BI layer and the aggregation layer, because we need more real-time alert and report, which needs for our users. So this is why we was looking for something. So we checked actually I checked the Delta Lake and Hudi and the Iceberg. This was the 3 table format on top of S3. Iceberg wasn't mature, so I I skipped it. I skipped it approximately a few hours later. I was trying, and because I didn't want to look to one company or self. This is why I choose Hudi, and I think. So, we mostly just one more info. So mostly we have the same setup as Jose just talked about. We are in AWS, most of our microservices in Kubernetes, and we run this whole thing in EMR. Next slide, please. So I try to, this is our high level architecture for this IoT use case. So the IoT devices, which is installed in the vehicles, hit the IoT bridge. Those microservices written in Go. The bridge is responsible to, like an MQTT endpoint, is responsible to put and persist the event into Kafka, and the data pipeline is starting there. It's in Go. That's those streaming processors. It's in Go because I need the very high performance and high concurrency processing for those events. And the bottom and you can see on the bottom. There are those colored box. Contains the Hudi framework. So mostly because these microservices were written in Go, we use protobuf in the internal communication. It was very easy to convert it to a JSON representation and put back to another topic into the Kafka. So it was easy to use the data streamer and sync and persist the events in the data lake. So this is our high-level architecture. If you want to ask, so I was able to achieve I use the data streamer in a batch mode, orchestrated by Airflow, and I was able to achieve a 3 to 8 minutes latency on the data lake, and that's totally enough, because if I need real time, so I need an event and I need real-time processing. Usually write a Go or a .NET microservice for that. So for the analytical use case and those use cases that work with tons of data. So I can't tell you how much data is that. Yeah. So it's pretty much that's it. Yeah. So next slide, please. So things that have worked well, I think it's same as Jose use case. So it's quite okay. I use 0.8.0 with EMR 6.4. I try to use merge or read table, but that was a little bit buggy. I'm going to cover it later. So documentation is quite okay. The community is also awesome. So I got every help what I was needed to move forward with this proof of concept. So as summarized, I'm pretty satisfied with the whole things. But yeah, yeah, pretty much it is. Can you please the next slide? Yeah, thank you. So I would like to talk about this a little bit more. So I'm not a Java developer, and I use these things with Python in PySpark, and the documentation is quite good, and I was able to figure out a lot of things. But it's sometimes it's very confusing. Sometimes it's very confusing. So I was socialized in Linux how-tos in Linux, so I can read, and I like to read the documentation. But sometimes that's just hard to understand how should I say that? Sorry, the right configuration for the data streamer and for the Spark API, because you saw that I use the data streamer to sync the telemetries and the events from the Kafka into the S3. So that's one of our leg, and the second leg is the aggregators and the transformators. So in the Spark API, it was pretty okay. It's pretty okay, the documentation. With the data streamer, so it could be better. And as I told you, I was trying to use merge or read tables because of the ingestion heavy use case, but it's very buggy with 0.0.0.80. But I'm trying to upgrade yeah, soon. So I just finished our first use case, so I try to go into production very soon, this month actually. So summarized, my challenge is to have the right information. If I figure out something, it's very hard. It's very hard to get the right information and configuration, because so how should I say that? So a part of the information is in the Apache Jira. A part of the information is in the Slack community. Part of the information is in the documentation. So I always read, and yeah, it's a little bit hard. So I think that's my biggest challenge. And I need to do a few things before I go production. So I need to learn how should I build my own Hudi. That would be great. That would be great. And I need to have more confidence. Go to production with this thing. I'm not 100% confident at the moment, but I will. So I will get there. Next slide, please. Oh, okay. I think Jose just covered everything. So I would say how to. So the documentation, that's okay. And I've read, I think, most of the blog. It was read by me, but even said that I'm not able to do a lot of things. So asynchron clustering. So I use inline clustering, and that's awesome. It works when it works. But I cannot figure out the asynchron clustering. Table repair. So I saw some documentation about the CLI. But what I need, it's a how to like documentation, and the documentation should keep in mind. So not everyone is a Java developer. Yeah. So you should. So my wish list. You should start a thematic YouTube channel. Actually, that would be very great. And I think it's easier than writing a documentation, because yeah, documentation is just a code which doesn't run. So I know that. But yeah, that is what I can tell about this. Next slide, please. So I would say everything works fine, and everyone loves this thing in the company. So everyone loves the data, which wasn't there just 2 months ago. And they are able to query this from Superset. So everyone loves it. Our main problem, actually, that my main problem is I'm not 100% confident to go to production with this thing, because I would like to read and learn more about the best practices around Hudi. How should I solve if how should I do schema evolution? Because I'm in AWS, as I told you, so it's backed by Glue, and Glue always do the partition fields and to the schema. So it's very hard to extend the schema with those approach I read in the documentation. So put the new columns and to end of the schema. So yeah, more how to and more and clearer documentation. So well organized, and that's all. That's all. Any question, guys?
That was awesome overview, Istvan.
Okay.
And the documentation call out for sure. I think we can do better there. So I'm interested. I write some documentation as well. I'm interested to chat with you more, and we can dive deep and come up with some cool plans. So
yeah. When I develop something, yeah, I hate to write documentation because that's just code which doesn't run. Yeah, but I am on the crying side. No, so,
yeah,
thanks very much, guys.
Let's do a party. We can talk more about those. Cool.
So I think
Okay.
just to add on that, I think sometimes it'll be helpful for us to get a like this kind of perspective, outsider perspective on the docs, because sometimes we tried to write the docs in like more expansive ways going forward, but some of it could be just traced to me. This is Vinod, by the way. Like I write very like at a higher like more. So I may like have blind spots where I'm assuming things, right? So this will be great if you can share like, oh, this specific part isn't clear, then we can actually do another pass and make it better and better. Yeah, but that'll be awesome. This outsider perspective would really be valuable for the community.
Okay.
And it will help many too.
I will.
So.
I will cry. Okay. Thanks.
All right, let's go to Gatsby just based on the time, so we can save time for Jorgen as well.
Hi, this is Gatsby. Nice to meet you. Let's move on to next slide, please. Yeah, so I'm from Forethought. I'm staff data engineer. Basically, the Forethought, we provide the online customer service with the human-centered AI with the mission unlock human potential through artificial intelligence. So our headquarters is based on the San Francisco, and then we have several hubs: San Francisco, Lehigh, Austin, Toronto, and then our specialist is AI NLP. You can go through that. Basically, I'm hiring data engineers. If you're interested, let me know, just email me or just kind of come to our Forethought website, just apply. Thank you. And let's move on. Next slide, please. So when I started using the Hudi, our first goal is, our kind of primary goal is building a robust data ETL pipeline that replicate the subset of the data in MongoDB. MongoDB basically data, we have a lot of update, and then even insert everything, and then this kind of ACID data has to go into the data lake. That's our main use case, and then data lake and then data warehouse to provide basically organization-wide accessibility at scale. Actually, this is very important, at scale, because even the data we have MongoDB, like, in our org people, they can access the data, but actually, it has some issue with with the scalability. So we needed some other place where we can support, the query or anything at scale. That was our high-level goal. Our tech stack right now is we are using MongoDB Atlas. That's our primary storage. And then mostly we are using almost everything. We are using the Amazon stuff, MSK Connect, MSK, Glue Streaming, Glue Data Catalog, and S3, and Athena, and SageMaker, and CloudWatch for the monitoring. So this is our the tech stacks. Next, please. So this is kind of high-level overview of what I'm trying to do. So from the left to the right, so all the data we have in MongoDB, and then all the write or update happening on MongoDB side. And then I wanted to have the same data on the data lake, because this data, the data we have MongoDB, it can be used by other team, for example, ML team, production team, there are multiple teams who wanted to use it at scale. Yeah, we can access it, we can query it, but it takes longer time. Sometimes give some load into our kind of, what is this, the slave node or kind of follow node or something like that. So we wanted to have some solution. So the decision we made is we wanted to build data lake and then data warehouse, so that other people, they can access it whenever they want it, and ML team, they can utilize the data whenever they want it. So MongoDB, there is multiple collections. We have 100,000 of the collections in MongoDB, and then whatever change happen on MongoDB, not all the collections, but some collection we wanted to monitor, that the changes even will be captured by the Kafka Connect we set up. And then the data go into the Kafka, the MSK, and then I'm using multiple topic, or sometimes I use one topic for multiple collections. if it is small. And then by using glue, I do the transformation like ETL formation, and then I write to the Hudi table. So if I have multiple messages in one Kafka topic, then basically I just kind of group the message separately and write to the Hudi table individually. And then this information go and then sync to the AWS Glue catalog. That's what I do. And then once the data is written to the S3 and then data is available on S3, then the data can be kind of queried by Amazon Athena or Amazon EMR if the ML team wants to use Amazon EMR. And then also they use SageMaker as well. So basically my end user who read this data is basically using the EMR, Athena, either Glue or something like that. There are like multiple users accessing this data. This is high level. Next, please. So things that have worked well. So I am using Amazon Glue, as you know now, and then I'm using Hudi 0.9. Basically, I don't have much option because I have to use, not have to, because I can use the custom plugin, but when I try to use Hudi 0.10.1 or 0.10 in Amazon Glue, it failed, it raised the exception and failed it. I think there is some kind of version issue. So I tried 3.1.2 and then 3. Some kind of bundle. I tried different version, and even I asked AWS support. I haven't got any kind of working version yet. So anyway, this is the combination. I'm using Amazon Glue plus Hudi 0.9. Yeah, I'm using Glue. So the data source is Spark data source. I am using copy on write with org level partition. I used to have COW, MOR, different table, but I had some issue with the compaction, scheduling compaction, small file, because I thought something magically happened behind, because if I enable async table services, I thought it happened automatically. But what I realized is basically async compaction didn't happen, and it generated a lot of small file. And then at the end, it makes a lot of problems. Like for example, S3 connection timeout, or sometime even the cleans, delete the commit before the compaction happened or something like that. So a lot of problem happened. And I used inline MOR compaction, inline compaction, but actually I don't see any difference between the COW and MOR after I enable the inline compaction. So I just said, okay, forget it. I'm going to use the simple version. So COW, that is what I'm using right now. And I also use a Bloom filter. Some people recommend me not to use Bloom filter, maybe go with the simple filter, because my baby, it's not really quite work for me using the Bloom filter. But like based on my testing, Bloom filter still works for me better with the pruning by range. So I'm going with it. And the writing, the main operation I'm using is observe. Most of the time there is a lot of updates happening, even insert happening too. So I just go with the observe, and even I have delete operation as well. I also use a lock provider. What is it? In order to use async table services, I heard that I need to set up the lock provider. So I was looking around, what kind of solution I can have, either DynamoDB or Zookeeper or Hive Metastore. But I realized that the MSK I'm using, it has Zookeeper, by default. So I'm just using that one, Zookeeper in the MSK. And they pre-combine, yes, I really love the deduplication before it right into the Hudi table. Recently through the selection, I learned that there are two different type of class for the pre-combine. Override with the latest ever payload, and then there's something called default something. So right now I'm using override with the latest ever payload. It works very well. Yeah, this is what I'm doing. Yeah, so far, it's good. It works well, and then it's already on production. Now I'm working on streaming the initial data into the data lake. That's what I'm working on. Next slide, please. Oh yeah, so this is just one thing I want to share. So I am using Glue. So Glue, Amazon Glue manages the service, right? So they expose a lot of metrics to the CloudWatch. So I was able to kind of build this kind of Grafana dashboard that I can use to monitor the current ETL pipeline status. For example, the glue the CPU uses in CPU uses in memory, even include the heap, and then shuffling read and write, and the Amazon has to read and write, batch processing status. For example, how many messages fetched from Kafka MSK, and then how much time it takes per batch processing, something like that. Even also, I can get how many complete tasks, and I can also see the number of completed tasks or something like that. That kind of information is available. So this gives me idea what happened if I tune or change certain Hudi configuration. Next slide, please. So the adoption challenges. So I didn't know. So actually 4 months ago, I didn't know anything about Hudi. I never heard about Hudi. Iceberg. I mean, some of my friends from Apple, they told me about Iceberg. Or like I didn't know anything about. I wasn't interested in this kind of tech stack. But 4 months ago, I started using using the Hudi, and basically I was very new, scratch. And then the first tech I used was Amazon Glue streaming. Like there wasn't enough reference or material. Only thing I was able to refer was like some kind of blog post from the Amazon. They say, oh, this kind of marketing blog. Like they say, oh, Hudi is possible to use in Glue, but like there is no kind of end-to-end kind of code how I can integrate with the Kafka and then Glue and Hudi. So anyway, some point I was able to make it run, but now another change was I like understanding how how the async table service work, what kind of expected behavior, what kind of, I need to understand what kind of expected behavior. Actually, this sentence doesn't make sense. So I didn't know what kind of behavior I should expect from the async table services in Amazon Glue. For example, as I mentioned, when I use MOR, when I enable the async table compaction, I thought, okay, since async cleaner works asynchronously, I thought async compaction also work somehow magically happen and then do the job. But actually, it didn't really happen, and they made a lot of problems. Even I didn't really use clustering because when I sync up with Amazon, they told me don't use clustering because when you do clustering, maybe compaction doesn't happen. Right now, I'm not using clustering, but at some point I really wanted to use clustering, but I don't use it because I don't know how it's going to work. So maybe later I want to use clustering, but for now I don't use it. So this was kind of the one challenge. Another thing was like, I think the Istvan, he mentioned that the documentation is very detailed, but like it's like there are some configuration like a little bit of redundant, like something for Spark data source, something for client. They're kind of saying, oh, you are enabling the async or even clustering something, but I don't know, like this was the difference between the configuration in Spark data source and then some configuration for the client. I was super confused. So what I can do was just learning by doing, so just A/B testing every single time. So even when I work on selecting the right classes for the given the record and partition, it was like a little bit confusing. Like somehow the Gluja fail and say, oh, you cannot assign null value for the partition. I never assigned the null value for the partition, and I realized that, oh, I used wrong, not incorrect the class for the partition or key generator. So I had to do some kind of what is matching, like, oh, try this, try that, and then finally I found out why it didn't work. And then another thing I want to address is, like as a beginner, I wasn't sure if I need to specify the record key as part of the partition. Yeah, and now it's very obvious because it makes sense. But when I used first time, I wasn't sure if I have to specify the field I specify in record key into the partition as well. But now I don't do it because now I understand how it works. But as a beginner, I think every single detail is kind of confusing when I use first time. And then understanding how async table service work. Yeah, I sync up with the AWS very often, but recently I just learned that basically Glue doesn't provide any kind of magic. You just say, whatever Hudi does, that's what will happen. Okay, so no magic in Glue. So async table service, I still need to understand how the compaction work, how the cleaner work, how the clustering work. So that's why I'm just going back to very simple thing like COW. Okay, just go with the simple first, and then I just want to buy some time. After I build the production ready stuff, already something is on production. After I buy the time, I will come back and start doing the investigation, research on MOR clustering again, and then I'm going to enable another, maybe another advanced services for feature. And then tuning the Hudi, the parallelism was little not sure which one is correct. Actually, I'm using 0.9, and then the default value for this parallelism is 1,500. And then people saying that, oh, your number is too high. But actually, I don't see any difference between 1,500 and then either 20 or 30 or something like that. I still see the similar performance in terms of, when I kind of, because always I do benchmark and I always do A/B testing to pick the right configuration. But right now, I don't see much difference. Maybe at some point I will see, but right now I don't see the problem. And then that's why I wanted to know like what kind of expectation I should have when I tune this number. Another thing is understanding the concurrency. Wow, this is another headache, like understanding the concurrency mode and lock and async table services. Because when I start using, because I enabled the meta table services, and I started to seeing some problem. Somehow the number of data I write doesn't match to the number of data I have on the data. Like I still have that problem. That's why I don't use meta table yet. Maybe I have wrong configuration. So I need to follow with the Hudi community. But like one thing I was confused was there is a little sentence there, like, if you want to use async table services with the meta table, metadata table, I have to set up the lock. But my question was, I am using single writer. Do I still need to still set up the lock? Because I have a single writer, why do I need to have lock? There wasn't any kind of clear answer about that. So I asked that question through the GitHub issue, and then Shiva and other people, they answered to me and they gave me the clear answer. So basically, if I want to use async table service, yeah, this one's I'm suddenly confused again. Yeah, so I think this is something not clear. Like I think if there is any kind of clear guideline or explanation how the async table and the lock and the concurrency mode should be set up. So again, the documentation is always good. And then maybe next slide, please. I have some kind of wish list. So a little more documentation for the user using Amazon Glue. So yeah, I'm from Glue. Maybe eventually, maybe I will move to Amazon EMR. But right now, I'm building the POC or a little bit production stuff by using Glue. But if we have some kind of documentation for the user cloud, cloud user, they would be awesome. So especially about the async table service, more kind of explanation how it, what kind of what's the expected behavior in cloud, like for async table services. Like the second bullet is MOR async compaction cleaner clustering. I think there should be more kind of clear kind of guideline explanation about the expected behavior. And then another suggestion is maybe we can build, if there is any Q&A board or reference board, some kind of board, people just go and then just kind of search it so that like they can see some kind of best practice and they can see some kind of previous question. I know GitHub issue also provides similar stuff, but if there is any kind of custom version of Hudi stuff, let's say somebody can find the answer by filtering like version, environment, or something like that. And then maybe that could be awesome. Then maybe we just write one answer, the right answer, best answer, and then it can be read by many people. And then you guys can also share the best practice, maybe per version, different version, or something like that. And then guideline in performance. When I tune, some certain configuration, of course I can say, oh, it's slower or slower than what? So I don't have any kind of the standard number. Like if you ingest maybe 10,000, 100,000 messages by using maybe Glue or EMR with this instance type, this is kind of expected maybe ingestion time or something like that. If there is certain kind of guideline, then I can say, oh, mine is slower than this or faster than this. Then based on that, I can focus on maybe the performance tuning. When I didn't have anything, basically, I am not sure if mine is slower, if mine is working fine or not. So if you guys can provide some kind of benchmark result with some data set, not really super fancy big one, just kind of small one first for the beginner. So that would be awesome. So that's all I have. Thank you.
Those are some cool ideas at the end there, Gatsby. I think we should follow up and chat more about those. Those be helpful and useful for others as well.
Oh, I'm sorry. What did you say?
I said those things that you mentioned at the end sound like really cool ideas, like the benchmark and the QA reference board. There's some Q&A on like FAQs on there, but I think we could do much better.
Right. FAQ, because I also use MongoDB community as well. They have some kind of list of the question and answer, so I was able to query or filter based on maybe version or something like that.
Yeah, we should do something like that.
Yep. Thank you.
Okay, I think we are running out of time now. For your
Raymond, I messaged.
We already agreed to skip it now.
Yeah.
So
yeah, cool.
Bergen will be our first one in the next call.
Okay, cool. Any other open floor questions?
I loved hearing the presentations today. Curious if others enjoyed the presentations, just to inspire new ideas, see how people are setting things up, and also like the feedback. I think these are things for the Hudi team. A lot of low-hanging fruits and ways that we can help.
Yeah, that's
for the
very great feedback. Yeah.
So very helpful to hear.
So sorry, go ahead.
It was like we started using Hudi for like 1.5 weeks ago. So just seeing these examples and hearing issues, hearing what has worked, it confirms like some initial thoughts as well. And then it's very nice to get some insights, basically.
Yeah.
Not alone in the trouble. Yeah. So I would like to ask one question. So the next stable release, the 0.11.0 is going to be released in March, end of March.
Yeah, that's the
okay.
Date, yeah.
Okay. Thank you.
There probably will be a minor release before that on top of like a 0.10.2, where which will carry a lot of more bug fixes. Like Shiva, you can probably. I know you were driving the dev list thread. Maybe you can give an update on that. Yeah.
Oh, so I posted a summary there. So probably we are directly going with 0.11 as per the responses we got from the thread.
Okay, sounds good. I'll catch up. Okay.
Thanks.
All right, so I guess that will be it. If no more questions, we'll close the session. Thank you, everyone. Great sharing.
Thank you.
Bye.
Thank you, guys. Have a nice day.
Thank you all.
Bye-bye.
Bye-bye.
Bye.
Thank you all.